All right, and we are back after the break. Thanks to everyone who stuck around. We got a great talk up for you next. It is called Zero Knowledge Proofs, the Key to Mass Adoption in Web3, and it's being given by Mauricio Magaldi, the head of product at Midnight. So please give a warm welcome to Mauricio.
Good afternoon, everyone. Pleasure to be here at ETHDenver. I'll talk a little bit about Midnight, why Midnight, and how we're approaching the use of zero knowledge proofs for amplifying Web3. This is pretty much a vision of what we're implementing and how we're getting it to market this year. So first, why Midnight? We believe that we can't afford the digital era without privacy. This is a human right in the era we live on. So utility should not come at the expense of privacy and ownership. We need to claim that back. So Midnight is a fourth-generation blockchain that aims to offer users and developers the ability to protect human privacy and the freedoms of association, commerce, and expression. And it is a blockchain that can keep a secret. We know that transparency is key, but for many things in our lives, we don't want the information to be flying around the internet and being mined for AIs or other purposes, right? So why did we choose to use ZK, zero knowledge proofs, for Midnight? We know that it's usually, the conversation is usually using ZK for scalability. ZK is originally thought of as a mechanism for privacy. And we're true to that in a way that zero knowledge proofs, they allow us to do something called programmable privacy, where you can actually selectively disclose the information according to what your use case or your own privacy and security paradigms are. And we chose snarks to do that because it's a simple way and a non-interactive way to actually continuously evolve. And one of the things that we are adding on Midnight is the ability to actually upgrade the snarks as cryptography evolves, and it's evolving super rapidly. We are able to bring on new snarks into the system and continuously evolve to that, which is not exactly what you can say for most of the blockchains out there. So programmable privacy, in our view, unblocks this ability to offer a widespread adoption of Web3, even removing and abstracting away that from users and developers. So the Midnight approach to privacy is composed of four larger elements: Kachina, our hybrid apps, Minotaur, and our dual token tokenomics. And I'm going to go through each one of them and hopefully make a good case for why these things are important and why we're choosing to use them and evolve on them. So in a traditional web application, we send a lot of information over the internet. Both sensitive and private data end up flying around, and this exposes not only users but also enterprises to becoming honeypots of data and of course being exploited. And no one wants that, even though this is the world we live in. So when we try to bring this to the on-chain world, we have these public chain apps that we know and love. But in that context, we allow correlation of public data and metadata, which ends up doxing not only the things that we did, but when we did it and how we did it. And obviously, this is not good for everything in life or in business. I would think that most of us here remember the Constitution DAO case, where they were beat up by the CEO of Citadel on the bid for the US Constitution because the data was public on-chain. They knew exactly how much more to bid to beat the Constitution DAO, right? So that is just one simple, very common example of how privacy plays a part in business and obviously in the lives of the people who actually chipped in for the Constitution DAO bid. So imagine that in a larger scale. And this is one of the things that definitely prevent enterprises and large corporations to fully embrace the use of blockchain in their core critical mission systems. So we're trying to play around that by the use of ZK and Kachina. So the way Midnight dApps work, the private data in the Kachina architecture never makes it to the blockchain. Only the zero knowledge proofs make into the chain and interact with the smart contracts. So you can have shielded data traveling around the blockchain across transactions. You can also have unshielded data as any other blockchain would. But the companies interacting with your zero-knowledge proofs can do that in the context of their applications. So if you're a DEX or if you're a DAO, you don't necessarily have to have access to the data, but you might want to do business logics just using information about the data, which is represented by zero-knowledge proofs. Kachina itself, it's a simple concept, and it's complicated to implement. I'll try my best to simplify the mechanics of Kachina that allow for selective disclosure. So in this architecture, you have a first step, which is understand the on-chain state. So you retrieve the current state from the chain. The logic in your application or in your wallet will generate the proof interacting with the proof server. And then the transaction is submitted back on chain, updating the state, whether with new shielded information or with new unshielded information. And that information on chain can actually be interacted with by the smart contracts. So the private data never makes it on chain, only the proof does. And that's how you can decide how much of the information you get to share with the world. And we can always be reminded that once something is known, it cannot be unknown, and once something is on the blockchain, well, then it's immutable. So we introduced also hybrid apps. Hybrid apps is a very interesting concept in which right now we have cross-chain apps. Most families' bridges are cross-chain apps where you have an application running wallets on two chains, and they have smart contracts on two different chains. We're working towards, and this is in research, we're working towards a mechanism called multi-chain signature, which will allow a single hybrid app interacting with a smart contract. And the call out is from one smart contract running on the chain to another smart contract running on Midnight. And in this way, not only we allow interoperability without you having to move your assets around, but the goal here is to actually make Midnight accessible to any chain. In this way, we can offer privacy to all of Web3, which is, in my mind, one of the missions for Midnight. So it's a very novel concept. We're in R&D for this, and we hope that this is going to make the lives of programmers and developers much easier to tap into the Midnight capabilities. We also are using Minotaur. Minotaur is, it stems from a paper written by the scientists at Input Output. And we're using Minotaur to bootstrap partner chains. Midnight is a partner chain to Cardano, and through Minotaur, we can actually inherit security from the Cardano validators. You can think of this as the restaking of ADA, which is the Cardano native asset, to secure Midnight. And with Minotaur's evolution, we'll introduce the multi-resource consensus. And multi-resource consensus is something pretty curious because imagine if you could bring Bitcoin miners to secure your chain in addition to your own staking, or bring ETH validators to do the same, or Solana validators to do the same. The goal here is to break the barriers and tribalisms of any other blockchain and allow Midnight or any chain using Minotaur to actually reward the wider ecosystem, which is pretty intrinsic to what we're trying to do with Midnight, is to just break the barriers. So the multi-resource consensus is on the roadmap, and we're already doing that with Cardano, and we're going to introduce that gradually with other chains. And this is one of those things that we've grew accustomed with in crypto, that I'm on my chain and I'm on my lane, don't touch me, I don't want to talk to you about anything. But in the sense, the technology is evolving in such a way that if we can actually tap into these types of resources in a coordinated manner, we can get the best of each chain for any of the applications we're running. And then we start going away from, I do this on the blockchain, to I solve this to my user, which is a core principle that sometimes we in crypto kind of tend to forget. So multi-resource consensus under Minotaur is one of those things that are so wildly untapped that I think when we bring this out to the world later in the year, this is going to blow people's minds. And one thing that we're bringing in with Midnight is this dual token tokenomics. Midnight will have two different native tokens. One of them is Night. Night is a governance token, and it is an unshielded token, meaning it's the same as any blockchain out there. But it has one specific functionality, which is it generates dust. And dust is the fee resource. It is a shielded resource, meaning it protects data and metadata. And it has a very interesting behavior. When you use dust to pay for your transaction fees, it will refill over time. And I know that the theme here at ETHDenver this year is the regenerates, and very much so. Dust regenerates in your wallet as you use it. If you move your NITE away, if you give your NITE token away, or you use it for some particular other application, it will decay over time. Dust will decay over time. So it's a very interesting behavior that allows a very interesting mechanics and use cases. This is not entirely novel, but the way that we are resolving for shielded transactions and unshielded tokens ended up being very elegant. And I think that the tagline here is it will generate dust forever. NITE generates dust forever, in the sense that if you hold NITE as part of owning the network, you can indefinitely use the network. We call it the Buffett pricing, like pay once, eat as much as you want. So if you own the network with NITE, which is our governance token, you can actually generate dust indefinitely, and as many times as you want, you can use the network paying dust. This is also a way for us to build regulatory compliant apps, because I'm a former chief data officer. I've implemented tools and applications in the context of GDPR-like regulations, banking secrecy acts. And with this type of tokenomics, we can actually enable the app developers to build regulatory compliant apps. And one thing that I feel very much like an advantage about this type of tokenomics, with the dual tokens, one being a shielded resource, the other one being an unshielded token, is that if you think about the traditional arrangement on fees on blockchains, you have the native asset for you, which you hope appreciates in price over time. But every time you need to use that chain, you chip away at that. You cannibalize your stash. You take away from your bag, and you own less of that chain than you would otherwise, right? So if you're a CFO, for instance, and you have the ability to use a system with high volatility in pricing, imagine this scenario. Not only you acquire the original asset, which potentially appreciated over time in price, and now you have to use that to run your business. So you're going to reduce that asset and pay that as an expense. Now, you don't know how much you're going to pay because this is very volatile, and you don't know how much you're going to pay when you have to refill your treasury with that asset, because the prices will move. So imagine if you don't have to do that, and you only have to hodl your asset, and it generates your fee resource that you can actually play with. And more importantly, if you're a CFO, you're locked in on the price because you have a CapEx that you bought. It's on your balance sheet as an asset, but you have repeating, refueling, regenerating fee resource to use the system. I don't think we can offer better predictability in price than that. So I would hope that people, when we put out the tokenomics paper later this quarter, will be able to blow people's minds with the level of detail and the ingenuity that the research team has put onto this. And being a former financial services guy myself, I'm like, this sounds pretty good to be true. Let's stress it. So we're running a testnet with all this tokenomics. When we launch testnet, the tokenomics is going to be available for everyone to try and crack it. So hopefully we'll be able to. So what's next for us? We are on testnet. So testnet's live. We have shielded tokens right now. You can program on the Kachina programming model using Compact, which is our Compact language. It is a TypeScript language with a circuitry library, so you can actually program your zero-knowledge proofs. Lace wallet. Lace is a staple Cardano wallet. It also supports Midnight. We are going next into what we call the scale testnet, which we're going to obtain support from the mainnet SPOs. SPOs is the validator acronym for Cardano, where we're going to introduce the unshielded tokens. We're going to bring some partners online that we're working with, and we're going to have further decentralized block production. And hopefully later this year, we're introducing mainnet. There is a roadmap of capabilities we're bringing to bear. And we're going to introduce composable privacy, in which a smart contract can actually tap into the proofs of another smart contract, which is pretty cool. Cross-chain bridges with our partners, and we're going to launch with decentralized on-chain governance for several governance actions. So if you're really deep into DAOs, I think you're going to like this. And we're here at ETHDenver. We have a happy hour at 4 today at the Centennial Room. And we're running also a hackathon with the Build-a-thon. There is a judging tomorrow, so check out in the Captain Ethereum stage here at the Build Hub. It starts at 11 tomorrow morning. And we're also running a virtual hackathon. So if you're a developer and you want to test your skills with TypeScript and zero-knowledge proofs, just scan this. It launches on March 10th. We're still picking up the theme, so I hope this is very enjoyable. There are prizes, and there's also bragging rights. So please do join us. And that was all I had for today. Thank you, and LFG.